Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about manual optical pyrometers appeared on the market in 1900 and are based on the disappearance of the filament of a lamp when visually comparing it with the image of the focused object. The operator varies the lamp current until the filament is no longer visible against the background of the focused hot object. The optical system of the pyrometer restricts the wavelength from 0.65 to 0.66 microns, which is the red area of the spectrum, and has filters to reduce the intensity of the radiation received, allowing the measurement of a wide range of temperature. However, only the temperature of incandescent or melting objects can be measured. Automatic optical pyrometers are like infrared radiation pyrometers and consist of a rotating disc that modulates the radiation of the object and that of a standard lamp that is incident on the multiplier phototube out of phase. This sends an output signal in the form of a square wave of direct current pulses that, when suitable conditions, modifies the supply current of the standard lamp until the radiation of the object and that of the lamp coincide in brightness. In some models, the signal conditioning is carried out with a microprocessor, which allows to have a precision of plus-minus 0.5% in the reading, with the additional possibility of working in continuous mode or of integrating radiation peaks or valleys, in the case objects pass in front of the pyrometer. A set of lenses similar to those of a photographic camera allows the reading of objects as small as 0.4 mm diameters. The infrared pyrometer captures infrared spectral radiation, which is invisible to the human eye, and can measure temperatures below 700 Celsius, replacing the optical pyrometer, which can only work effectively at higher temperatures, where the visible radiation emitted is significant. The measured temperatures range from values of less than 0 Celsius to more than 2000 Celsius. Here, we can see how this type of pyrometer works. The lens filters the infrared radiation emitted by the area of the object examined and concentrates it on a photoresistive temperature sensor that converts it into a current signal. And through an internal algorithm of the instrument and the emissivity of the focused body, passes it to a temperature value. The output signal can be analog 4 to 20 mA or digital. The ratio of the distance from the object to the sensor and the size of the image on the lens can be from 2 to 1 up to 300 to 1. These pyrometers, in contrast to the optical ones, must consider the emissivity of the body. They have an emissivity compensator to compensate, in addition to the loss of radiation in bodies with emissivity less than 1, the loss of radiation by vapors, gases, fumes, or transparent materials that get in the way. They have a faster response than thermocouples, of which I have 3 videos that I will leave in the eye, and they reach 95% of the final value in 1 millisecond. So they are used to measure temperature of moving or rapidly heating objects. Its accuracy is plus-minus 0.3%. Regarding infrared thermographic cameras, these allow to store thermographic images with their temperature distribution and process them on a computer, which is of interest in preventive and predictive maintenance in the industry. Its measuring range is from 0 to 1200 Celsius and has an accuracy of plus-minus 2%. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós! Adiós. They have an emissivity. They have an ¿No qué? ¿Está muerto? ¿Se murió? No. ¿Sí?